So, welcome everyone to our CMIT lecture series on technology from industry perspective. Today's topic is mass personalization in healthcare through 3D printing, and our speaker is Kyle Shapland. So, I've been asked to introduce Kyle. Right? He works for Materialise. Most of you are familiar with Materialise, but maybe not all aspects of Materialise. So looking at his LinkedIn profile, it is immediately clear that he has a good sense of humor. Like, I'll let you go and check that out. So I first met Kyle a few months back when he visited our labs, and then I met him at ADZ, which many of you have met him at as well. And I was having a chat with him, and earlier I had thought that Materialise, it was the company that made mimics. But speaking to him, I realized that actually Materialise is far more than just mimics, and heavily involved in personalized medicine. So, right. So he's Kyle, by profession, is a commercial account manager who specializes in facilitating hospitals with setting up point-of-care facilities, and also helping medical device manufacturers make the most or maximize their workflows. He also engages with educational institutions, universities in particular, to produce the next generation of biomedical professionals. And I think he's ideally suited to talk on this topic because of what he does with Materialise. So over to you.
Thank you very much, Hans. Good morning, ladies and gentlemen. My name's Kyle Shapland, and I'm the Australia-New Zealand Medical Account Manager for our medical software solutions here at Materialise. I would like to extend my thanks to Peter Lee and Meg and the whole ARC CMIT team for giving me the opportunity to speak today. I did want on record that the work that the CMIT team has done has been fantastic, especially through some trying times over the past couple of years. And from an industry perspective, thank you for your continued work. It's also brilliant to have this hybrid event as we finally get to be face-to-face again, and hello to those that are streaming in on their computer. Today's topic is mass personalisation in healthcare through 3D printing, with a particular focus on point of care. So our agenda today will be, I'll give you a brief introduction to Materialise for those that aren't familiar. We'll talk about mass personalisation in healthcare at a bit of a high level. What is point of care? Some point of care success stories, and then a bit of a brief chat on how to implement a point of care facility. With our HQ based in Leuven, Belgium, Materialise has become the global backbone of the additive manufacturing industry. And our CEO and founder, Frida, encapsulates what we are all about here with this quote. Our mission is to innovate product development that results in a better and healthier world through our software and hardware infrastructure and an in-depth knowledge of additive manufacturing. Over the past 30 years, we've grown in expertise through the continuous addition of new people who bring fresh ideas and knowledge. Our machine park in Leuven is extensive, with over 160 3D printers, a wide variety of technologies and materials such as plastic and metals. We've also grown globally. So we now have 24 offices in 18 countries around the world. We want to be close to our customers, understand their needs, and to be able to support them in their own language. And from the start, Materialise has just had a very, very strong focus on research and innovation. Currently, we have 8 production facilities. We have production in the US, Japan, Czech Republic, Belgium, Poland, China, and Germany. We also have 6 competence centers, and we look at those as production plus specialized research and development. So they're in the Czech Republic, Belgium, Poland, China, Malaysia, and Germany. We believe mass personalisation is a revolution that will truly lead to better, more predictable treatment that's accessible to everyone. At Materialise, we're proud to be playing our part in facilitating this ambition through image-based planning, AI and 3D medical printing, empowering researchers, engineers, and clinicians to embed personalised care into their daily practices, and driving better and more predictable patient outcomes. And we hope sharing this vision with audiences like yourselves will contribute to this as well. As you can see here, Materialise probably helps around 50,000 patients a year with either the usage of our software or implants and devices. We've probably done 350,000 now patient-specific models, guides, and implants in our company's history. And we estimate it's over 5 million patient scans have been analysed using our medical software. Materialise works across the entire healthcare ecosystem to co-develop new applications and build clinical evidence together. So one thing we are incredibly passionate about is bringing academic institutions, like where we're sat here at University of Melbourne, bringing them together with hospitals, and also encapsulating medical device companies as part of that, so that all three are working together for best result. Let's have a quick chat on mass personalisation in healthcare. And I wanted to start with a bit of a simplistic, high-level view of it for those that are not as technically minded as myself. So, brief analogy on the concept of mass personalisation is the idea of taking what has been, stuff that is one size fits all, or traditional ways of doing tasks, and making it relevant and specific to either the individual or the task. I think that's very important. It's individual or the task. In the past, many everyday tasks used to be based on generic knowledge. So if you imagine previously, everyone had the exact same map to decipher how to get from point A to point B. With technology today, we use GPS navigation systems to get from point A to point B. They will have a very predictive way of traveling from point A to point B, that's personalized either to your mode of transportation, whether that be in the car, on a bike, walking, to your driving preferences, and is also able to predict how much time it will take if you take alternative routes. So how does this fit into a medical capacity? In mass personalisation and healthcare, we're always targeting unique pieces. So we've seen an evolution over time where small objects such as hearing aids could be cost effectively manufactured on a very large scale already more than 10 years ago. So since then, we've seen mass personalisation possible in guides, and now it's starting to appear in metal implants, although predominantly in quite niche applications still. We'll see the scalability appear in other applications that are more demanding in terms of cost or manufacturing complexity, driven by cheaper materials and technologies and a more efficient use of manufacturing equipment. Let's get personal. So mass personalisation is one solution that will help tackle future medical challenges. We have the opportunity to understand individual anatomy in better, deeper ways than ever before through imaging and genetics. And we've translated that to personalised diagnostics. So the opportunity to transfer that to personalised care is still very, very open. Personalised care where treatment is right first time for each patient, avoiding unnecessary cost and improving satisfaction, and where solutions can be implemented cost effectively at scale. So what's exciting is that the technologies are already here or are coming right now to make this happen. And in addition to meeting patient expectations, mass personalisation has the potential to bring about much of the needed changes we need to see in our healthcare system. Thought I'd show you an example of this in the current today market. Acetabular revision surgery has a pretty bad prognosis with traditional techniques. Mostly very high failure rates occur. So we're talking about re-revisions. It's a fact that 15% of revisions fail. 27% of patients are getting re-revisions due to suboptimal fixation and suboptimal biomechanical reconstruction of the joint when combining standard components. What's even worse is that a hip re-revision, they're three times more likely to fail compared to the first revision. So fortunately, through mass personalisation and 3D printing, we can break the revision cycle for these patients. Here at Materialise, we've introduced a personalised acetabular implant solution called a MACE to the market, and have performed a large amount of cases, showing very strong outcomes so far. We're reaching very high patient satisfaction levels now, and a strong implant survival number that truly contrasts the poor situation that standard solutions typically offer. Surgeons can thereby gain that confidence in a lasting solution for their patients. Switching gears now to another 3D printing example here is the here and now use of 3D imaging, surgical guides, and printed implants for personalised craniomaxillofacial surgery. So as you can see, over 30% of CMF devices in France are already personalised, which is a really large number, a large part of the market. So the innate complexity and very personal emphasis of facial surgery means that patient-centric solutions are increasingly utilised for improved outcomes, not just for the patient, but for the hospital as well. So the NHS recently highlighted the use of planning guides in this field, stating that having accurate 3D surgical guides reduces time in the operating on the operating table. It's a fantastic result for clinician and patient. This obviously helps with reducing mortality rates, and also alleviates pressure on a whole bunch of surgical resources, from surgeons to their surgical staff and equipment. Use of such technology in CMF is fast becoming the norm, and the reality is that not adopting it means you're probably going to be left behind. So, mass personalisation enables better, more predictable treatment, accessible to everyone. Many assumptions are currently made about mass personalisation in healthcare. Assumptions like the use of 3D imaging, printed tools and implants is undeniably more beneficial, but that it only applies in select cases, such as those of the complex acetabular defects I mentioned earlier. The benefits we're seeing: fewer surgical revisions and less time in surgery, improved predictive accuracy for procedures, and high levels of reduced readmissions are all very real. But this doesn't mean that that mass personalisation healthcare will go mainstream. We believe ultimately that this assumption is wrong. Use cases in CMF, for example, obviously with the nature of it being extra sensitive, or acetabular defects that are so severe they call for drastic measures, are merely precursors, we believe, of a trend where mass personalisation is happening at scale, a shift which you here are all part of on a day-to-day basis, predominantly with your research. So it's exciting times ahead. Our experience of this transformation to date means that we believe that this here is the future, and it's not just hypothetical. It's a future based on a number of different approaches, techniques, and technologies and partnerships. We know for a fact can overcome key challenges by making personalisation feasible. So more medical teams knowing how to personalise, understand capabilities, and benefit from the tools and infrastructure which make adoption simpler in complex settings, often involving multi-departmental teams, making it more affordable. So by the solution supporting value-based care without being cost prohibitive, and ultimately adaptable. So through solutions that respect the rapidly evolving digital and medical landscape, to give healthcare teams the room and flexibility to change and leverage emerging innovation, and to ensure continued improvement is possible. And ultimately, current markets for personalised medicine only continue to prove this as well. So as you can see, the US global personalised medicine market alone is forecast to reach 2.4 trillion just this year. So what is point of care? So previously, clinicians once were isolated from other departments, can now work with software, create models, and personalise a patient's care all in the hospital. So the roadmap to recovery is individualised and specific to every patient's needs. So 3D planning and printing has enabled clinicians to go from scan to personalised treatment, including patient-specific 3D virtual modelling through to 3D printed anatomical models manufactured directly at hospitals at the point of care. These tools can be used across a hospital to easily connect with teams from different departments. For example, if you look at the diagram here, you can see that there is a potential for collaboration across many different hospital departments to set up an in-house 3D printing centre, which can, if they have the relevant skill set, remove the need for outsourcing 3D printed applications. Industry and hospital are identifying the next applications where printing at the point of care is valid, for example, for guiding solutions or even for implants. So we believe that workflows where this can be introduced in a safe and effective way and that deliver a clear benefit over outsourced manufacturing are in the process of being identified and should be enabled. We've scaled knowledge from our internal processes to the hospital and learn the additional complexities and regulatory burdens that creates. So we're ready to learn with other pioneers what it takes for the next frontier of point of care 3D printing to happen. Just a couple of highlights in 2022 in the point of care 3D printing world. Globally, the quality and regulatory framework has become even more important. We've seen plenty of thinking beyond anatomical models. So clinicians now in the US and in Europe in particular have adopted the use of anatomical models for pre-surgical planning and patient education. And they're really looking now at expanding that to patient-specific guides for a whole raft of their clinical outcomes. And today, nearly 450 hospitals around the world have some form of on-site point-of-care 3D printing labs supported by Materialise that provide efficient, personalised care for their patients, including 85% of the top 20 hospitals in the US. So it's growing and it's growing rapidly. This data you can see we've published from our user base, showing the growth and also global distribution of hospitals investing in 3D printing. So it's currently taking some business from what was historically outsourced and creating brand new opportunities for hospitals, industry, and even academia. And as you can see on our little island here in Australia, we've got 9 here already. It's a great start. This here is what we consider probably the 4 options a point of care facility has to maximise patient care. So starting from a CT or MRI scan, doctors can visualise the anatomy of their patients in 3D, whether that be on screen or physical model. It allows them to precisely plan surgeries and increase communication with their team, patient, and the patient's family. A validated software like our Mimics Innovation Suite also provides surgeons and engineers the capacity to design precise surgical cutting guides and patient-specific implants, improving the surgical outcomes and patient recovery times. So reported benefits of setting up a point of care facility, obviously that better preparation for surgery, reduced surgical time and cost, reduced readmissions, interdepartment collaboration, something that barrier still needs to be knocked down in many of our hospital institutions, especially here in Australia. They get very, very siloed. Patient education, when patients understand what the process is, what the surgical outcome is going to look like, the acceptance and the healing process can be much more productive. Internal hospital training and education, and then having a point of care facility in a hospital is a really good driver of innovation for that hospital. It brings a lot of those that are maybe a bit more proactive in their innovative thought together, and it can really drive the hospital's innovation outcomes. So I see there being 3 steps to a point of care facility that hospitals can look to attain, and I just thought I'd go through those steps briefly. Really, the first step is using validated software for surgical planning and creating virtual models. That's your first step. Your second one is producing 3D printed surgical guides and models in-house. And then your third step is 3D printing patient-specific devices. So if we look at the evolution of imaging, historically imaging has been used to facilitate surgical planning over the years. With the advancement of in imaging technology, we're also now seeing a massive shift towards 3D modeling. So lately there's been an increase in the use of 3D virtual models, not just for surgical planning, but also as an education tool for patients to better understand the anatomical complications and to enable medical practitioners to have a tactile visual aid to describe medical procedures. So this is a recent report by Shapiro as the new computer assisted 3D templating adds precision to the correction of distal radial and ulnar deformities. This paper found that using validated software to do surgical planning and virtual modeling actually reduced the overall operative time by 1/3 to 1/2, which is massive. It's massive, massive time saving. So this is obviously a great outcome for patients and for clinicians. This paper here also did a very similar bit of research, but it's also quite remarkable what it found. So this paper looked at printed models, but also showed a correlation with using virtual modeling and surgical planning in cranial maxillofacial procedures. I'm sure you would all agree, saving an hour on average in the operating room and $3,720 per case is a great outcome for patients, clinicians, and our medical institutions. Step 2 is printing guides and models. 3D printing at the point of care, as we've discussed, is a big trend and is only growing. And it's driven by clinicians and industry in particular, aiming to improve the level of personalisation of complex cases. For example, where a lot of this was driven from originally is in paediatric trauma and complex cardiovascular anatomies. 3D printing at the point of care really started with a few pioneers that we work quite closely with, for example, at the Mayo Clinic and the Boston Children's Hospital. So solutions are becoming more integrated into hospital IT infrastructures. They're more tailored to clinical use and have introduced certification to the level of the printer used in the hospital. So there's really now that collaboration between clinician, IT and engineering to get some of these results. So having a dedicated facility in-house can cut days off the process, support innovative initiatives and result in lower overall costs incurred by the hospital. And once your process in place, the cost saving can be quite large. Reduce procedural risk and OR time, improve patient safety and lower readmissions, seamless collaboration between those departments again, improved communication with patients. The benefits are all there on tap. So it's a big trend, as I explained earlier, in the US and Europe, and it's here to stay. So capturing that logistical cost and the collaborative benefits. And research we'd sort of worked on a couple of years ago showed that by 2022, and it's very much on par, is 25% of US clinicians are now practicing on 3D printed models of the patient prior to surgery. So it's huge. This case here, so this was Yuntar, and this was surgical treatment for posterior dislocation of hip combined with acetabular fractures using preoperative virtual simulation and then three-dimensional printed models. There were 16 patients that were used in this trial, and of those cases in the 3D printing group, they had a mean operating time reduction of 43 minutes. And for hip procedures, that's massive. And it's quite a great safety outcome for patients in particular. So although more evidence is required to further move medical 3D printing into the mainstream, there's certainly a growing body of evidence, as you can see, demonstrating improved clinical outcomes and returns in the form of cost saving, cost avoidance. This one here was a cost-benefit analysis of 3-dimensional cranial maxillofacial models for mid-facial procedures. 31-minute time save, which is nearly 10% of OR time, and $1,000 a case. It's big. This one here was 40 cases that were reviewed for this. It was 3-dimensional printed models for surgical planning of complex congenital heart defects. It's actually an international multi-center study. And of those 40 cases, 50% of cases, the 3D printed model helped redefine the surgical approach. It's big. It's quite an impact. And for our oncology fans, this study here, I know 94% of surgeons rated the models very helpful for treatment planning. It's quite a high number. But when they were looking at three-dimensional printed anatomical models as planning aids in complex oncology surgery, a model to give that surgeon confidence is a massive, massive deal. You know, when you're looking at half or full nephrectomies in oncology, the distances and the depths is between, like, it's the small margins are success or failure. So it's great to sort of see this sort of outcome happening. And then I also wanted just to show everyone how great color printing is now starting to look. And you can imagine as a patient, if your clinician is sitting there and going through your complex issues with something that kind of looks like it could have just been cut out of you and shown in front of you, it's pretty impressive, right? Like the detail is massive. The detail is very, very intricate. And I think it allows people to really engage with the process. Step 3 is medical devices. So as you can see here, there are many printed devices that can be produced, from craniomaxillofacial to acetabular to knee and osteotomies. What's important to remember, though, is that there's a very high skill level that is required in this. The regulatory burden and upfront capital costs kind of makes it somewhat hard to do in the Australian market currently, but we see over time that will, as the cost of that reduce and the skill set increases, it'll be a lot easier to integrate. This is an area I would encourage academia and industry to guide our hospitals in best practice, and industry in particular. Now, industry in Australia, they take the risk, but they've also then learnt from the risk they've taken. And I think that there's a really good opportunity for industry and hospital to work quite closely together on how they get this together and make it work properly. I thought I'd share a couple of quick examples of some success stories by having a point of care facility. So this here was the world's first face and double hand transplant. As you can imagine, there is no cookie cutter off the shelf solution when it comes to a procedure of this magnitude. And so one of our clinical engineering teams based in the US was able to work together with the surgeons at NYU and the patient to prepare the surgical plan. And then we were able to design and print over 180 patient-specific guides to make this happen. I thought I'd share this one here. It's a nice local one. So this was an LAA closure guided by Personalised 3D printed cardiac reconstruction by the team at Victor Chang. A 74-year-old man with a history of atrial fibrillation was referred to the Institute for consideration. The aim was to use the modelling and modelling software to replicate the patient's anatomy and use patient-specific models to guide surgical procedures, such as a left atrial occlusion. They did a CT scan of the left atrium, and left atrial appendage was obtained and imported into Mimics, where a 3D reconstruction, semi-automated segmentation was performed in the software. This was then converted into an STL file and printed to simulate the mechanical properties of the atria. There were 3 different types of devices then inserted into the model. A 3D color-coded map was provided according to the causal deformation, and these 3D models were then used to find the best device size. So what this demonstrated was the potential for clinical utility of 3D printing for both device sizing and avoiding procedural complications. So obviously you've got super excited and you now want to go and work with your local hospital, or you're in a local hospital and you now want to implement a point of care center. So how do you go about it? So first of all is choosing the right tools. When it comes to choosing the right tools, it's imperative. So when you are working with your hospitals and particular hospital administrators, there is going to be a a large interest in the printer. It's pretty much human nature. If I can touch it, it's tangible, it's interesting to me. And therefore, there's some overlooking of the software that's probably needed to maximize the outcome. So this must be balanced. Would really highly recommend large amounts of research and discussion is had on this point in particular. Identify your key stakeholders. I like to look at the fact when you approach a hospital to help them work in this area, you want to talk with medical director or heads of some of the major departments. You want to ascertain who the engineers are within the hospital, and engineers that want to upskill, that's always a really good one. Your clinical champions in your different departments, and then who your admin / procurement / finance support are going to be for the project. So yeah, really identify those key internal and external stakeholders, really lock down your key clinical champions across the departments, and then bring the administrative, IT, finance, procurement team together as well. The areas that I would recommend you go and have a look at is your orthopedics and trauma department. Have a look at your CMF and plastics, cardiology, oncology, neuro, surgery, training and education. And really what you want to be talking to them about is how many cases they're doing in a year, and then try and ascertain from the amount of cases they're doing, what is the percentage of complex cases they do that they feel if they had some virtual surgical planning or some virtual modeling could have made the process easier or could have maybe given them a better outcome. Funding is everyone's favorite question. It's getting funding, especially in the Australian market, is not the easiest thing in the world, but having a look at it, different funding options that are normally available to you are research grants, philanthropy, hospital funding, and private investments. We tend to find startup costs are often covered by research funding, philanthropy, and those innovation grants, while there's limited or no reimbursement originally by payers for complex case planning, including 3D printed cut and drill guides. Existing reimbursement opportunities generally occur only on a case-by-case basis. I recommend that you make sure you know how your work will be funded into the future. So work out how that can be funded within the hospital system and within what you believe would be your customer or client network within the hospital. The regulatory environment is becoming increasingly more complex to manage. So hospitals, researchers and companies addressing some of these challenges are being confronted with a complex regulatory environment. Our previous webinar, I highly recommend everyone goes and watches it. Our speaker, Nick Zepps, is a true expert in this area. Our recommendation is, if in doubt, seek someone like him out. The new and evolving TGA regulation is only an example of new hurdles to overcome for both hospitals and industry, which they make some sense from an Australian healthcare and consumer and policy perspective, but at the same time, it really puts pressure on users and manufacturers to be able to deliver new products to the market in a viable and cost-effective way. So from a Materialise perspective, we see the need for best practices to be established. So mitigating risk and complying with latest regulatory standards. I cannot stress the importance of how seriously you must take this. I thought it was very interesting, the 2018 SME Medical Additive Manufacturing and 3D Printing Annual Report actually showed 29% of respondents saw regulatory as its greatest challenge. With 61% of respondents acknowledging the regulatory environment is a challenge to their 3D printed applications. So I don't know whether we look at that and go, they've either missed the point that it's probably there should be more that see it as a burden, or that at least a third of industry is stressed and struggling with the regulatory hurdles that it needs to jump over. So please take it seriously. This year I put together just to sort of show you that there is a really good way to be able to capture value when it comes to your point of care facility, but there is a number of different questions that you need to ask yourself. So really the discipline to measure value is what will allow you to continue to get funding internally and externally. I break those down into your tangible clinicals, your intangible clinicals, tangible operational and financial, and your intangible operational and financial. From a tangible clinical perspective, successful surgical simulation for procedures never done before. So let's have a look at how many, over what time period, how can we design a feedback form for practicing and requesting surgeons, improved clinical outcomes. So which procedure specifically, how will we define an improved clinical outcome, how many procedures over what time period, avoiding unnecessary procedures. So which procedures specifically, how many over what time period. From an intangible clinical perspective, you want to get an enhanced understanding beyond what is possible with imaging alone, increase surgeon confidence. How are you going to measure that? Improved patient experience. Again, how are you going to measure that? From a tangible operational financial perspective, so reduce time in the operating room. So how will we define and measure that? There's lots of factors that go into it. Incremental revenue capture from surgeries that would not have been possible without patient-specific anatomical models. So again, how, why, and over what time period. Increased revenue from billing codes, so that from preoperative planning and post-processing. How does that look to your hospital? How do you define it? And then your intangible operational or financials. Improved branding through innovation technology leadership. It's quite a key part now for a lot of hospitals. They are very much looking internally to what can we show the world that we do, and patients are far more educated today on what their hospitals are doing in terms of innovation. So it's very much something that needs to be looked at. What increased process efficiencies, how are you going to measure that? And then what marketing and public relations advantage is a point of care facility potentially going to give you. The next thing you really need to go and look at is a certified workflow. So once you've got all your little ducks in a row, you need to work with your engineer and really put this together, because if you don't, it will fail. So there's 6 essential steps we see are needed to be considered for a certified workflow. So imaging, so how you're obtaining your DICOM stack from your radiologist or from PACS. Your segmentation, so converting that stack into a mask. Conversion, turning that mask into a 3D part. Editing, so how are we cutting the model to visualize the internal structures. Preparation for printing, so editing that 3D model, such as labeling or support bars, and then the printing process itself. Collaborate, collaborate, collaborate. So it's really the biggest, it is by far the most overarching step of any point of care facility. And if you fail to collaborate, your facility will not survive. It's been evident, and the ones that have are thriving, and the ones that haven't are dying. So obtain that volume, start working with your prime internal customers, and make them happy, and work with external companies, students, radiology techs, to make the whole process feasible. Does this mean that we believe that all patients will end up with a 3D printed implant? Perhaps, but in many applications, we have a lot of personalization benefits to capture in the meantime. So from introducing planning to making planning predictive to creating more options for intra-op guidance and beyond. Planning, I'm sure you've all seen, is clearly the foundation of all personalization workflows. So going up, the complexity increases, planning becomes more difficult, and we rely on algorithms or clinical engineering teams to support the clinician's judgment and expertise. The closer we move to the patient, the more relevant and indispensable 3D printing becomes as a technology, conveniently transferring the 3D information available in software to the patient. However, on some levels, we see 3D printed solutions coexisting alongside other technologies. For example, for planning, 3D printed models are often used in complex cardiac anomalies, such as congenital disorders, where for other applications, they're often complemented with more traditional advanced visualization or the newer virtual reality options. So ideally suited for educational environments. For intra-op guidance, we see a place for robotic systems or augmented reality navigation next to patient-specific 3D printed guides. However, moving beyond the standard, especially in the patient, puts 3D printing in the driving seat as the key enabler for mass personalization workflows. And just to finish off, generic in the long term is dead. So one size fits no one. So I'd like to ask you all to join us in making the transition away from the generic to make mass personalisation the future of healthcare. Together, we all can make that difference. I hope I've convinced some of you who might have been a little skeptic, that mass personalisation in healthcare is not for the exceptions, but for the many, and that is possible, and it's happening. So thank you very much for your time.